All right, so before we move on to the next section, we really need to sit down and make sure we understand the difference between internal and external forces. So I'm going to make a kind of very straightforward system of links here. So we've got three links that are overlapping, and each of these links is attached to the other link by a pin, right? So a pin there, a pin there, woo, and then it's attached to the ceiling by another pin joint. All right, so there's our pin, and then we're going to apply a force F acting downward. All right, so we've got these three links, and if I ask the question, what is the reaction at this pin at the top, then we can draw our free body diagram of the whole piece, right? We don't care that these three things are jointed together, right? Because we know that this force acts all the way down. So we can just grab this piece, right? Drop it over here and draw our reactions, right? We have a pin reaction, so we know we have AY and AX, and then our force down here, and then we can go to our solution. So the one, our solution. So the one interesting thing, right, is these are pin joints, right? We would expect them to have reactions, but the reality is we don't care, because if I were to draw, so let's think about this. The only time that we care is when we were to break this apart. So if I were to draw this exploded, right? So here's this pin right here, and the next joint right here, and then the next joint down below. I'm going to offset these a little bit. Then the pin forces matter because we've taken it apart. So let's draw this. So we got AY, AX, we'll call this BY, BX, again, right, BY, BX, CY, CX, CY, CX, and then our applied force F. All right, one thing to notice, what the key point here is that we have a link, and then the second link, and then the third link. And if we were to put these two back together, by just the fact that these are both the same pins, BY and BY are equal, and BX and BX are equal. So when they're attached back together again, and this whole thing right here is a Newton's third law, right? Newton third. By Newton's third law, BY and BY are equal, and so when we put this back together, they cancel. And BX and BX is equal, and so when they put this back together, they cancel. And so what we end up with is the internal forces canceling each other out, and so they don't appear in the external load. So we have this free body diagram of these three links that we drew of this initial arrangement. We have a force here, and only the piece that we took apart at the top comes into play. The forces at this pin and the forces at this pin are canceling each other out by Newton's third law, and they don't show up until we explode them. So take them apart basically like we did here. And so what we're going to do is we'll use this Newton's third law experience for internal forces to help talk about how forces exist inside materials in the next couple of chapters.